subtract. So when 0, 0, subtract is 0 and borrow is 0. When 0, 1, okay. So 0 minus 1 is not possible. So what we do, we take one borrow. So borrow is 1. When we are taking the borrow, so it is a 1, 0, that is 2. Binary code of 2. 2 minus 1 is the 1. So subtract is also 1. Okay. When it is 1, 0, so 1 minus 0, subtract is 1 and borrow is 0. And when it is 1, 1, subtract is 0 and borrow is 0. Okay, so the equation for subtract is A XOR B, and for borrow is not A XOR B, X XOR Y. Okay, X XOR Y, and for borrow it is X bar Y. Okay, now if we go with the demux, so here the Y is there, Y bar is there. If I apply the X, okay, so X bar Y selected plus X Y bar is selected. So that means this is the difference equation. Now we check the borrow. So if X is 0, Y selected. So the equation is X bar Y. Okay. So borrow and subtract both equation will be correct. Now if we go with this one, so the difference is again X bar Y plus X Y bar. For the borrow, it is X bar Y plus X. So that is X plus Y. If we check third one, so again X bar Y plus X Y bar. This is the borrow. Difference is okay. These two options are same.
No, sir, that is difference because B and B. First is B and then
Okay. So here borrow is this one and difference is X bar Y plus X. That is X plus Y. That is also wrong. That is also wrong. In this case, this is wrong. Okay. And if we check this one, so it is a X bar Y plus X Y bar. That is wrong. If we check the equation, so it is a X bar Y. That is also wrong. This is the borrow equation. Okay. The first option is correct. Now this question. In the circuit shown below, W, X, Y, Z are select line, W and X are the MSBs. Okay, so this is MSB, MSB. Okay, so 0 and 2 are connected with ground, 1 and 3 will be connected with 1. So at this point, what is the equation? 1, that means W bar Y, and 3, that means WY. Okay, now this will be go into these 2 points, and these 2 will be the ground. So X bar Z bar Q plus X bar Z into Q. Okay. So from that 2 point, I just take a X bar Q as a common. So Z plus Z bar is eliminated. Now put the value of Q. So X bar W bar Y plus WY. So X bar Y is the correct option. And if I am not eliminating this Z, so X bar Y Z plus Z bar. That means x bar y z plus x bar y z bar is also the correct option. Okay, this option is only for confusion.
So where's that multiple option? Need to select
Yeah, it is a multi-select option. No? Select the correct options.
okay, just I choose only one.
Yeah. For the circuit shown below with the input ABC or primary input, identify the input combination for which the output line of the active decoder D4 is 0 while the other input D0, D7 are equal to 1. Okay, so basically it says that D4 is 0. Okay, when the D4 is 0, when the apply 1 0 0. Okay, if it is 0, so that means 1 dot C bar is equal to 0. If C is 1, that means it is 0. 1 dot C bar is 0. If C is 0, that means 1 dot 0 bar is 1. Okay, so from that one we know that C is 1. Because if C is 1, then it will become 0. Okay, now we go to this point. If C is 1, that means C bar is 0. C bar is 0, so 1 and 0 if we apply on a NOR gate, so it becomes a 0. Okay, and if it is 0, that means B is also 0, otherwise it becomes 1 because it is a OR gate. So C is 1, B is 0. Now we go to the first one. So if B is 0, so 1 and with 0 and 0 ending with 0 becomes 1 because it is a NOR gate. Okay, 0 and 0 ending NORing with is equal to 1. So that means A is also 0. Clear?
Yes.
Now in a given circuit A and B, 4 bit input is applied to the comparator circuit. The output of comparator is used in a 4-bit adder. The output of 4-bit adder 5-bit data, where C out is the MSB and the output data bits are, and S0 is the LSB of the output data bits. Okay, so this is your complete data. Okay, now the output of the given circuit is when A is 12 and B is 9. So that means A is greater than B. So this one will be high. Okay, if this one will be high, so it will be go into this point. That means we are getting a B0 bar, B1 bar, B2 bar, and B3 bar. Okay, because it is a OR gate, XOR gate. If B0 is 1, sorry, if one input is 1, so it will be behave as a invert. Okay, now your A2 is 12, B is 9. We have to take a invert. So 0, 1, 1, 0. And as well as C is also 1. Why? Because this is 1. So here we are getting 1. Okay, and if it is 1 again a OR gate, so we are getting 1 here. So that means C is also 1. So 0 plus 0 plus 1 become 1, 0 plus 1 become 1, 1 1 plus become 0, carry 1, 1, 1 becomes 0, carry 1. So this one. So the output is 1, 0, 0, 1, 1. Okay. Now, if I say the output is the last carry bit is if we are not consider. Okay. If carry bit is not considered, so what we do? We neglect this carry and this is the output. So you can check the output is 3. 12 minus 9 is becomes 3. Already discussed in last class, Friday. This type of question. Okay, mock.
Yes, sir.
Okay. If we neglect the carry, so the output is 3. But we consider in the question it is mentioned that we have a 5-bit output data. So that's why if we consider that one, so it is a 1001. So 10011. If it is a 4-bit data, that it is 3. Okay, now when a less than b. So a less than b, that means it is 1. This becomes 0 and this becomes 1. Again, it will be go to the, so we are getting a naught bar, a1 bar, a2 bar, and a3 bar. Okay, and simply it is b, not b. So we are not getting this. Okay, so b is 13, 1101. A is 6, 0110. But it is a complement, so we are taking the 1001. And C is also 1 because now this one is 1. If it is 1, so this become 1 and C is 1. Now if we add this one, so 110 and 1, 1 carry 1, 1, 1, 1 becomes 0 and 1. Okay, again if we neglect this one, so we are getting a 7. We are getting a 7. B minus A, that is 7. Okay, now when both are same, A is 0, B is 0. So that means this is 0, this is 0. So we are getting 0 here. But now A is equal to B. So this one 1. So C in is again 1. C in is again 1. So A is equal to 0. Sorry. 10, 10, and C in is 1. Okay, no complement. Why? Because this one is 0, so it will be go 0, it will be behave as a buffer. That means B naught is passed. This is also 0, so it will be going to the XOR, one input of the XOR, so it is also behave as a buffer. So this XOR gate is also buffer, behave as a buffer. So directly A and B. So 1, 1, 1 becomes 0, 1, 1, 1 becomes 0, and 1. Okay, the answer is this. Okay, now when the input A is higher than input B, then select the suitable operation performed by the circuit. So when A is higher than B, so we are doing that A plus B bar. Okay, A is higher than B, then A 12, we take a complement of B. So that is B bar, and that is also C is equal to 1. So A plus B bar plus 1. So that means A minus B operation is performed. Okay.
Okay, sir.
Now, if you have any doubt, you can ask. No doubts?
No, sir.
So now we will start week 9 content. 13 minutes remaining. So start the week 9. You started. You start watching week 9.
Uh, no, sir, not yet.
Hmm, week 9. The deadline is 8th. So we have a Wednesday class. So I just brief you about the week 9 content. Just give me a minute. So basically, week 9 is related to the about the sequential circuit. Till now, we discuss only the combinational circuits. Combinational circuit. Now, from week 9 onward, we go with the sequential circuit. So basically, what is the meaning of sequential circuit? The circuit that follows sequence, or basically we can say that are synchronized. Wait a minute. Hmm. So basically, the circuit that are synchronous. Synchronous, that means they are operate with clock frequency. Okay, they are operate with the clock frequency. Why clock frequency? Because a clock frequency or clock signal is a signal that is used for the synchronization. Like if I just say that two different particularly persons who start moving, okay, and they want to meet at some particularly point. So what they do, they just synchronize their clock. It is now 10, so now we start moving. Okay, so basically, if we are going for the synchronization, so the synchronization, the best thing is that we required a clock frequencies. Okay, so similarly, like in our computers, or basically, if we are talking about the microprocessors that have some clock frequencies, so that clock frequency basically tell us that when it will be operate, when it will be time taking, when any process if we start, so when it will be start. Because sometimes what we do, we just click like I just open a Word. Okay, I just open a Word in my computer. So what I do, I just click a multiple times. Okay, so that particularly process will be go on a queue, and every process will be executed after with a clock signal. Either the rising edge of the clock, either the falling edge of the clock, or either the positive level or either the negative level. So basically, if you are talking about the clock that is used for the synchronization, so every clock have four particularly points where they get synchronized. That is up to the point. Okay. If I am talking about this one, so this is the rising edge. If I'm talking about this one, so this is the falling edge. Okay, this is the positive level. This is the negative level. Okay, so that particularly clock is used to synchronize. So that means the sequential circuits are the circuit that is operated with a clock pulse. With a clock. Now, the point is that if we are talking about the positive edge, rising edge or the falling edge, so we know that that particular time taken for the rising edge is very less. Very less. Okay. Ideally, it is zero, but in a signal system, we already not a signal system. Basically, if we are taking some particular time or transition from the zero to one, or it will be taking some time. The time is very less, but it will be take time. So ideally, it is zero, but it will be take a minor time in a picosecond or less than that one. Okay. Similarly, for the falling edge, again, the ideally it is zero to change the level from zero to one or one to zero, but some time taken. But this particularly, if I am talking about the ideally, so it will be a single edge, single time instant at which it is changes their level. So the sequential circuit that particularly vary with the edge, we call them the flip flop. We call them the flip flop. That means where the synchronization is better. If the time taken for rising or falling edge is very less, so it is the more synchronized. Like I am saying that one thing is that I will start at 10 a.m. from my home to office. This is the one way. Second is that I just move from home to office between 10 to 10:15. So either I will go with 10:1, 10:2, 10:3 up to the 10:15. So which one is the more synchronous? At particular time instant 10. So similarly, thing is that if time taken from for 0 to 1 and from 1 to 0 is very less, so that particularly is more accurate synchronization. So generally, the we are using for the sequential circuit is the edges, either the falling edge or the rising edge. Okay, so basic initial sequential circuit is the flip flop that will be synchronized with edge, either rising edge or falling edge. Okay. Second, that is not as much accurate, but that is also synchronous. It is called the latch. It is called the latch. That is synchronous with level, either the positive level or negative. Okay. So we have a initial level, initially synchronous circuits. Basically, initially sequential circuit we have classified in two categories: the devices that are synchronous with the edges and the devices that are synchronous with levels. So the devices that are synchronous with the edges is called the flip flop. The devices that are synchronous with the level is called the latches. Okay. Now, with the help of this flip-flops, we can create a more other devices, like we can create a counters. Okay, we can create a registers. Register basically your memories. Okay, we can create a uh, finite state machines, FSMs. We can create a mm, counters, registers. Yeah. So these three devices we can create with the help of flip-flops. So basically, flip-flops are the essential sequential circuit that are synchronized with edge. Latch is also a initial basic level of the sequential circuit, but that are trigger or basically synchronous with layer. Okay, so we start with the latch. Okay, then go to the flip-flop, then register and counter. Okay, after that we go to the FSM. So this is the complete structures of from week 9 to week 12. So in the initially week 9 we start with the latch. Now there are four different type of latches we are using. One is the SR latch or SR flip flop. Okay, then JK latch and JK flip flop also. T latch or T flip flop, then T latch or D flip flop. SR basically the name set reset. Okay, JK that is given on the name of scientist. T is toggle and D is delay. Okay, so SR latch, set reset latch or set reset flip flop, JK latch, then T toggle latch or toggle flip flop, and the D delay latch and delay flip flop. So we have four types of latches and four types of flip flop. Okay. Now with the latch, we can implement with the help of NAND gate or NOR gate. If we design a latch with the NAND gate and NOR gate, the truth table for both will be different. The truth table of both is different. In place of flip flop, if we are talking about, so either we design with the NAND or with the NOR gate, truth table is same. Truth table is same. So XR latch, or basically latch is the initial unit of the flip flop. Okay, initial unit of the flip flop. Any doubt?
No, sir.
So if we start with if we start with the latch, so basically I think so we start with the D flip flop. No, I think the left. I think we start with the SR latch. That is better. So if we are talking about the SR latch, so again I just say that latch will be implemented with the help of NAND and NOR gate. So if we design with the NAND gate, this is S and R. Okay. So I just say that this is the Q and this is the Q. Okay. So if SR, I just say the Qn and Qn bar, Qn plus 1 and Qn plus 1 bar. Okay, what is Qn and what is Qn plus 1 bar? Qn is the previous output. Okay, Qn is the previous output. So if I take the SR00, Qn I am taking 0 and 1. Okay, that means the previous store output is something. Okay, previous store output is there, and that particularly output is either it is 0 or it may be the 1. So if S is 0, R is 0, this is the NAND gate. What we are getting? We are getting the, if any of the input is 0, the output of the NAND gate is 1. Okay. So either the previous output is 0 or the previous output is 1. We are getting next output is also 1 and 1. 1 and okay. Now if 0 and 1, 0, 1. Okay. Now S is 0. Or basically if I say the R is 1. Now R is 1, that means depend on Q. If Q is 0, that means Q bar is 1. If Q is 0, that means the next output is 1. If it is 1, it is go in this direction. So 0, 1 again a 1. 0, 1, so it becomes 1. It will be go into this. So 1 and 1 becomes 0. And it is 0, so it is 1, 0. Now if it is S is 1 and R is 0, previous state output is 0 and 1. So if R is 0, that means Q bar is 1. If Q bar is 1, S is also 1, so 1, 1 becomes 0. Okay, and if it is 1 and 1, 0. Okay, if both are 1 1, so it will be dependent on the second input. Second input is the q. I'm taking the q as a 0. So it will be go 0 here. So this one 1, this will 0, that means q bar is 1. If q bar is 1, s is 1, so q is 0. Okay, and if it is 1, so 1 is going in this side, 1 is already applied, so q bar is 0. If q bar is 0, it will be go here, so it is 0, it is 1, so both will be down. Okay, so you can see that if SR is 0 0, it is not dependent on previous. 0 1 not dependent on previous. 1 0 not dependent on previous. But it 1 1, so it is dependent on the previous. If previous is 0, so we are getting a 0. If previous is 1, we are getting a 1. Okay, so here the output will be dependent on the previous also. Clear? Now, if I replace this NAND gate with the NOR gate as Q R, we are not mentioning the Q and Q bar. We are saying that output A and B. A and B. A. Now SR, QN, output A. Now if it is 0 0, 0 1, 1 0 and 1 1. 0 and 1, 0 and 1, 0 and 1, 0 and 1. So if SR is 0 and 0, okay. So if both input will be 0 0, we are getting no. If both input is 0 0, so it is dependent on the QN. Okay. So I just say that it is 0. So that means 0 0 B become 1. Okay. If B is 1, so that means A is 0. And if I assume the previous output is 1, that means this one is 1. So if it is 0 1, so you can see that B is 0 and A is 1. Second, if it is 0 1, so here it's 0, it is 1. So if R is 1, any of the input of the NOR gate is 1, output is 0. If output is 0, this one, so 0 0 become 1. So in any case, it is 0. Okay. Now, in this case, S is 1. So if S is 1, A is 0. A is 0. If A is 0, B is 1. Okay, and last, if both input is 1 1, so it becomes 0. Clear? Now, if you see that table, can you see here when the in the NAND gate it is 1 1, then the output dependent on the previous state. It is 1 0 0 in the NOR gate. It is 0 0. The output dependent on the previous state. When it is 0 1, output is 1 0. When it is 1 0, sorry, 0 1, output is 1. Okay. The 1 0 combination, the output is 0 1 0 1. When it is 1 1, the output is this. So that table is completely with the NAND and NOR gate. The table is completely different. The complete is different. Now, what we do here is that we have to equal these two tables. So that means either we can implement with the NAND gate or with the NOR gate. In both of the cases, the truth table is same. The truth table is same. So we use one more NAND gate, and that will be controlled with the clock. Or we can say that we can use one NOR gate here, and that will be controlled with the clock. So we can control with the clock also. We can basically eliminate the effect of either I'm using the NAND gate or NOR gate. For every scenario, it will be the same. For every scenario, it will be the same. So it is a flip. So that is the problem with the latch is either we implement with the NAND gate or with the NOR gate. The truth table is different. Okay.
Okay.
The second problem with the latch is it is not controlled with the clock. Either we use the clock and that is the level triggered clock. So basically, it will be vary for a duration, complete duration. If it is a positive level clock, so in a positive level, the output will be changed at several times. If it is a negative level clock, so in the negative level, the output will be changed at a several times. So there is no particularly effect of that clock pulse. So we can add a one clock that is the S triggered clock, and that will control the behavior of the output. So that is flip flop. So we convert a latch unit into a flip flop by connecting two cascade combination. Okay. So when you are go through with the content, so we will discuss in the Wednesday class in more details. So that is a brief idea about what is the sequential circuit. Sequential circuit that is use clock for the synchronization. In the sequential circuit, first is the latch unit. The latch is level triggered. Okay. Then we go to the flip flop. Flip flop is the basically as triggered. With the help of flip flop, we can design a counter, register, then FSM final pixel. So we are going to discuss all these things in the next 4 weeks, 9, 10, 11, and 12. Any doubts?
No, sir.
Okay. I think we stop here.
Yes, sir. Thank you, sir.